Welcome to another video on logarithms. From this video onwards, we will basically be solving equations, whether they are logarithmic equations or exponential equations, but making use of our laws of logarithms together with our laws of exponents. Okay, so what are we covering in part 5? We will solve logarithmic equations. We will solve exponential equations using our knowledge of logarithms. All right, so first of all, what does it mean to solve an equation? That is to find the value or values of unknowns, e.g. values of x, that when substituted into an equation will render the left-hand side and the right-hand side equal. Okay, so most of us at this time, we know what it means to solve an equation, whether it is quadratic, polynomial equation, logarithmic, exponential, or whatever, trigonometric equations. We know what that means. We will do the same, but we will be working with the logarithmic and exponential equations. Okay, so let's look at the first question here. We are solving logarithmic equations. We will use the laws of logarithms to solve equations, both exponential and logarithmic. And let's see the first one. The first few questions I will try to, line them up using the system, and then I will use my hand. Okay, so here's the first question. C1, because in the previous video we were using B. First question is solve the equation log to base 6 of x plus 2 plus log to base 6 of x plus 1 equals 1. So notice the stuff in the bracket is the argument of the logarithmic expression. So the argument here is x plus 2, and here it is x plus 1. We are used to seeing just a single value or a single term under the argument. So always remember to treat this x plus 2 together, everything inside the bracket, as one object. Okay, so that's how we're going to be able to simplify this easily, right? Now, if we're going to solve this equation, that means find the value of x that when I substitute here and here, the left-hand side is going to end up being equal to the right-hand side, which is equal to 1. Now, to solve this particular logarithmic equation, we need to use the laws of logarithm, and you may pause the video and think about which law would be relevant in solving this particular problem. And if you don't need to think very far, and this is addition of two logarithmic terms. So if we are going to solve, we need to put them together, and to put them together we need, because this is a sum, we need the product law, which says that log to base A of capital A plus log of B is log of the product of the two. So using that same idea, I'm going to keep one log, it's going to be under one log, and then I'll take the arguments and multiply them together. And so I have log to base 6 of the first argument is x plus 2 times the second argument, in this case it's B. Here we have x plus 1, so we'll put x plus 1, and we will equate that to 1. So the left-hand side has been combined or compressed under one logarithmic expression, as we have already shown in the previous videos, all right? So this must be equal to 1. And now there are two ways we can go about this. The first is to simply convert from logarithmic to exponential notation directly. We know, for example, that if I have log to base k of a equals to p, like that, then I can write a is k to the power of p, like that. So a is k to the power of p. So using the same reasoning, I can take my arguments. Here the argument is a. So here my argument is the whole expression, x plus 2 into x plus 1 is my argument. That represents a. So I can say that argument must be equal to 6 to the power of 1, right? In the same way, like that. So x plus 2 into x plus 1 must be equal to 6 to the power of 1, which is in fact just the same as 6, all right? Now that's one way. We haven't solved it yet, but that's one way to get rid of the logarithmic notation. Of course, the other way would be to make use of another law of logarithms, and that's the unity law, which is to say that log to base A of A is always equal to 1. Okay, so where I see 1, I can remove it and put log to base A of A, but the A that I choose, I must be sharp about it. Since this is log to base 6, I'm going to make this a be 6. So log to base 6 of 6 must be equal to 1. So I can replace this with log to base 6 of 6. Okay, what am I saying? Since 1 is the same as log to base 6 of 6, I can write the left-hand side is the same as it was, but now the right-hand side I can put log to base 6 of 6. So if log to base 6 of 6 of some argument is the same as log to base 6 of the argument 6, then the arguments must be equal, in which case I can say that term and that term are the same, and you can see those two are basically what we have written here. So you could think in two different ways to solve this problem. Our task now is basically just to solve this, and as you can see, that's a quadratic equation. So I will remove everything and move that up, and if we expand that, try to expand that, pause the video, expand it, you should end up with this expression here. So x squared plus 3x minus 4 equals 0, and we can solve this either by factorization, or we can use the quadratic formula, and we end up with using the quadratic formula, or you can also use your GDC, your graphical display calculator, and you should end up with the values of x being -4 and x being equal to 1. Please pause the video and solve the quadratic equation and confirm that the solution is -4 and 1. Okay? Now you have to be very careful when you get to this stage, because we are dealing with logarithms. Okay? It is possible that one of them or both of them are not solutions. Okay? And how do we know this? We know that the argument of a logarithmic expression must never be a negative number. So if I substitute -4 for value of x here, I will end up with log to base 6 of -2, which is not possible. Similarly, if I substitute it here, I'll end up with log to base 6 of -3, which is again not possible. We cannot find the logarithm of a negative number. We already discussed that in the previous videos. And so a value of x of -4, although it is a solution to the quadratic equation here, it does not satisfy, it does not hold for the logarithmic equation, and so we have to discard it, okay? Why? Because the argument of a logarithmic expression has to be positive, has to be greater than 0. So, since the argument x plus 1 must be greater than 0, x plus 1 and x plus 2, this is supposed to be x plus 2 here, so x plus 1 and x plus 2 both are supposed to be greater than 0. Because of that, the x value, the solution of x of -4 is disqualified, and therefore our solution to the logarithmic equation that we were given is simply x equal to 1. Okay? All right, let's see the next question. Again, remember, here we are basically just solving a logarithmic equation, and some of them will be exam type. So this is video number 5. In video number 6, it will purely be exam problems from the IB or Edexcel or the CIE and so on. Yeah. Solve the equation. A half log to base a of x plus log to base a of 5 is log to base a of 45. So of course the best thing to do here, first of all, you cannot have the coefficient of log there, so we're going to use law number 3 to move it up, right? So we will move that up, which is allowed, and then rearrange the terms of the logarithmic expression like that. Okay, I've moved the half to the top, and then I've moved this to the other side, and we have log to base a of 45 minus log to base a of 5, like that. And so now what we can do is, this is the same as the square root of x, so I have log to base a of the square root of x, and here I can use the quotient rule, which says log of a minus log of b is log of a over b. So log of 45 over 5, okay, like this. So log to base a of the square root of x becomes log to base a of 45 over 5, like this. All right, 45 divided by 5 is 9, so that's log to base a of 9. And now the argument, so the bases are the same, and therefore we can equate the argument. So the square root of x must be equal to 9, If the square root of x is 9, we can square both sides, and x is 81. And that's the solution to that logarithmic equation, right? Let's look at the next one. Question number 3 says solve the equation log to base 3 of x plus 3 minus log to base 3 of x minus 1 is 2. Again, please pause the video and see if you can use the method we've used earlier to solve this particular logarithmic equation. Assuming you've done so, this is a difference of two logs, and therefore we need the quotient law, which says that log to base 3 of that argument there, x plus 3, divide by, because we are subtracting, we will need to divide the arguments, so x plus 3 divide by x minus 1, and this must be equal to 2. All right, so again, I could choose to write this as log 2 log to base 3 of 3 or log to base 3 of 9. Alternatively, just change from logarithmic notation to exponent notation, and I have the argument, which is all that stuff in bracket, must be equal to 3 to the power of 2, like this. Let's be faster. Okay, so this must be equal to 3 to the power of 2, which is the same thing as 9. And now all we have to do is to cross multiply. That is, think of that as being over 1. If you cross multiply, you end up with x plus 3 is the same thing as 9x minus 9. Okay, and rearranging that quickly, I should show you that 8x is the same as 12, and therefore x is 3 over 2. And that is the solution to that logarithmic equation. Should be easy. Let's look at the next one. This might require the use of a calculator. Let's see. Right. Be careful here. This is base. The bases are different now. This is base 4, but this is base x. So when you have a situation where the different terms have different bases, what you think about quickly is the change of base law or rule. Okay, so what we're going to try and do is to change this to base 4. Instead of using base x, we will change this to base 4. Okay, so like as follows. This is already in base 4, so I don't have to do anything about it. So I will change this to base 4. Therefore have log to base 4 of x plus 5. And now I change that. This becomes, if I'm going to write this under base 4, this is going to be log of 4 divide by log of x, and each of them under base 4. So log to base 4 of 4. So this 4 here is that 4. And now I'm going to get log of x, but also under base 4. Okay, I've changed the base, and this is equal to 6. Now what I need to do, log to base 4 of 4 is 1. And so what I want to do is just multiply through, because I have a fraction here. I want to get rid of the fractional term. So what I'm going to do is I'm going to multiply each term by log to base 4 of x. If I do that, this is going to be log to base 4 of x squared, because I'm multiplying it by itself. All right, and here if I multiply by log to base 4 of x, it's going to cancel, and log to base 4 of x is going to appear on the right. So like this, multiply by log to base 4 of x. So log to base 4 of x squared plus 5 into, that is 1, and if I'm multiplying by log to base 4 of x, they cancel. So I'm basically just left with the 5, and this must be equal to, log to base 4 of 4 is 1, so this is equal to 6 into log to base 4 of x. So I can write that way. All right, I will move everything to the other side. If I do so, then I have log to base 4 of x squared minus 6 log to base 4 of x. All right, and then plus 5, because log to base 4 of 4 is 1, and this must be equal to 0. Now when you look at this, you should notice that this is in fact a quadratic equation. All we need to do is to either replace temporarily, you can let log to base 4 of x be y or t or whatever you like, or leave it like that if you know what's going on. This is a quadratic equation. So to solve the quadratic equation, we could use the quadratic formula. Okay, using the quadratic formula here, I'm moving that up. So we are looking for log to base 4 of x using the quadratic formula that the a is 1, b is -6, and c is 5, if you understand what I mean with this in quadratic formula. So then log to base 4 of x, or t if you like, must be equal to the negative of b, so minus of -6, okay, negative b, plus minus square root of b squared, okay, plus minus square root of b squared, which is 36, minus 4 times a times c. 4 times a is 1, 4 times 1 times 5 is 20, so we have a square root of 36 minus 20, okay, and everything divided by 2a, which is 2 times 1, which is 2, like that. And if you simplify this, this is square root of 16, that is the same as 6 there, and this one here is the square root of 16, and if we simplify this, this is 4, of course, and if we simplify, this is 10 over 2, which is 5, or 6 minus 2, which is 2 divided by 2 is 1, so the values here are 1 and 5. So log to base 4 of x is either 1 or it is 5, like this. Okay, or it is 5. And so all I have to do is to change to index notation. X must be 4 to the power of 1, or x is 4 to the power of 5. So x is 4 to the power of 1, which is 4, or x is 4 to the power of 5, which you can see is 1024. And these are the solutions of that logarithmic equation there. Okay, let's move on. Example 5 or question 5, solve the equation log to base 9 of x plus 2 log to base x of 9 equals 3. Your job is to solve this equation. So I can pause for a moment and give you some time to solve the question by yourself. Please pause the video and try to solve it. But if we assume you've attempted to solve the question already, let's see how we go about the answer here. So again, I have log to base 9 here and log to base x. So of course, we need to change base, all right? And we are going to change so that everything is under base 9, all right? So then I have here, I'm going to have log to base 9 of x, and I have plus 2, and this I will change under base 9, so I'll have log to base 9 of 9 divide by log to base 9 of x, like that. This is 1, and everything here equals 3, so I can write this as log to base 9 of x plus 2 over log to base 9 of x equals 3. And if I multiply through by log to base 9 of x, I have log to base 9 of x, everything squared, plus 2 must be equal to 3 log to base 9 of x. This is another quadratic equation. If you check carefully, you should see this is another quadratic equation. I have log, I'll write this slightly higher. So I have log to base 9 of x, everything squared, minus 3 log to base 9 of x, and plus 2, I think, equals 0. Okay, we can let this temporarily be some x or t or whatever you like. So t squared minus 3t plus 2 equals 0. This is a quadratic equation using the formula t, which by the way is log to base 9 of x, must be minus b is 3 plus minus the square root of b squared, which is 9, minus 4 times a times c, which is 8, everything divided by 2a, which is 2. So log to base 9 of x is 3 plus minus 1, over 2, which is what? 4 over 2 is 2, and 2 over 2 is 1. So we are saying log to base 9 of x is 1, or log to base 9 of x is 2. So from here, x is 9, okay, or x is 9 squared, which is 81. And these are the solutions of the logarithmic equation that was given to us. These questions are not difficult, so once you get the hang of it, it becomes rather easy to solve them. Here's the next question. Solve the equation log to base 2x of x squared equals 3. Okay, let's deal with this. Very, very short. Now, of course, it would be easy to change the base. We can change to base x if we wanted, but otherwise we can also just write this. Let's see. So we can write this, if we change this to base, first of all, of course, we could write this as 2 power x to the power of 3. We can write this as log to base log to base 2x of x squared is 3. I can change to exponential notation, and I will have x squared is 2 to the power of x cubed. So x squared is 8x cubed. I can write this as x squared minus 8x cubed equals 0. I can factorize x squared out, right? And I have 1 minus 8x outside. So obviously x is 0, or 8x equals 1, in which case x is 1 over 8, like that. And these are the potential solutions. If I put x is 0, I cannot have log to base of 0, so this answer is disqualified, okay, because I have an x here. I cannot have a base of 0. But if I have 1 over 8 here, then it should be possible for me to get the correct answer, which is right. Okay, so that's basically it for this particular question. The other way, of course, would be to change the base and write this as log to base x of x squared over log to base x of 2x, and equate that to 3, right? If I do that, then this is 2 log to base x of x, which is the same as 1, divide by log to base x of 2 plus log to base x of x, which is another 1, and this equals 3, okay, like that. So we are saying 2 over log to base x of 2 plus 1 is 3. And so cross multiplying take this as being over 1. If you cross multiply, we end up with 2 being equal to 3 log to base x of 2 plus 3 there. And so clearly 3 log to base x of 2 is negative 1. Log to base x of 2 is negative a third. Change to exponential notation, 2 becomes x power negative 1 over 3. We cube both sides, we get 8 is x power negative 1, and so x is the same as 1 over 8. We end up with the same answer. Clearly this is a slightly longer approach than the first one that we did, but it doesn't really matter. If you substitute in the value that we got here, substitute here, you should end up with the correct answer. Should see that this is in fact true, okay? Yeah, this power 3 will give us that, so that means it is 3, makes sense. Okay, in other words, a quarter to the power of 3 will be 1 over 64. So definitely 1 over 8 is the solution to the logarithmic equation. Okay, so you just need to choose the best approach that will give you your answer fastest. The next question, C7, says, okay, so this one is an exponential equation and it's going to require the use of a calculator. We want to make use of our knowledge of logarithms to be able to solve this. we were able to solve directly exponential equations like these ones if this could be expressed as a base of 3. This would be easy to solve without logarithms. But when you have a question like this where you cannot reduce this to a base of 3, then we need to make use of our knowledge of logarithms. Okay, so what do we do here? You want to take the log of both sides and you choose which base you want. In particular, in this case, obviously I'm going to go with base 3. So I'm going to write, the left hand side is going to be, I'll write this as log 2 base 3 of 3 to the power of 2x minus 1 must be equal to the log 2 base 3 of 40, which I can get easily on my calculator. So this requires the use of a calculator. Using our third law, power law, I can move this exponent to the side, and now I have 2x minus 1 log base 3 of 3, which I know is 1, is log 2 base 3 of 40. Okay, in fact what we are saying is that 2x minus 1 is log 2 base 3 of 40, which I can get very quickly on my calculator. But first of all, I can write this as 2x is 1 plus log 2 base 3 of 40. So x is, in fact, hope you can see that, 1 plus log 2 base 3 of 40, everything divided by 2. Or I could have written a half of it. Yeah, like this. I could have expressed that as a half of 1 plus log 2 base 3 of 40. And I can put that easily on a calculator to find the answer. I don't think I need to move any further beyond that. Use your calculator to find this. In many cases, examiners will ask you to leave your answer in exact form, in which case you leave it like that. Otherwise, you will be told to give your answer to a certain number of decimal places, in which case you make use of your calculator to arrive at that answer. Okay, we'll look at the next question. To keep this video short, I decided to solve these questions up to number 10, and then I'll put all the other questions in the problems. There is a playlist on problems, so I'm going to put all of them, all the other questions there, including examination type questions. Okay, so after you've solved this question, I have some other questions I will show you here, but to see the solutions you will go to the playlist on problems, and I will put all the solutions there. Okay, video solutions accordingly. All right, so let's do the next 3 questions. The first one of the 3 remaining questions will be solve, and we have 8 to the power of 3x is 2 to the power of 2 times 4 to the power of x. Of course, I don't need to use, I can use logarithms here, but I really don't need to, because I can write this one as a base of 2 and the whole thing here as a base of 2, like this. As maybe I do it using 2 methods. So I'll write this as 2 to the power of 3 times 3x there. That's that one there. And I'll say this is equal to 2 to the power of 1 times 2 to the power of 2 times x, like that, which is 2 to the power of 1 plus 2x. Okay, and so 2 power 9x equals 2 to the power of 1 plus 2x. So this is using exponential method, and so if the bases are the same, the exponents must be the same. So 9x must be 1 plus 2x, 11x, that's not 11x, that is 7x. So 7x must be equal to 1, and x is 1 over 7, like that. That's the way to do it. The normal way to do it is using exponents, but if I had to use logarithm, I'd take the log of both sides. Log to base 2 is probably the best, and I'll write log, let me use a different color now. So I would probably write log to the base of 2 of 8 power 3x must be equal to the log 2 base 2 of 2 times 4 power x, like that. This is 3x log 2 base 2 of 8, which is 2 power 3, must be equal to log 2 base 2 of 2 plus x log 2 base 2 of 4. I'm moving faster. This is 9x log 2 base 2 of 2, which is 1, and this is 1 plus, and this becomes, this is 2 power 2, so the 2 goes forward, and I have 2x log 2 base 2 of 2, which brings me back to the same thing, and I'll arrive at the same answer. From here, x must be equal to 1 over 7. I hope you can see what I did there. I've moved a little faster, discussing the log 2 base 2 of 2 here as well as here. This is 2 squared, the 2 goes to the side, so 2x, we are left with log 2 base 2 of 2, which again disappears, and we have that. Okay, next question here. 2 log 2 base x of 7 plus log 2 base 7 of x is 3. Again, this is base x and this is base 7. So we want to change so that we are on the same base. My suggestion here would be to change to everything to base 7. Please try that out. Perhaps I can start it out and you can complete it. But of course, the first thing we want to do, so change the base here so that we have base of 7. So I'll write, this becomes 2, and I have log of 7 over log of x, and I'm keeping base 7, so this will be base 7 there, and this will be base 7 here. All right, and this is plus log 2 base 7 of x equals 3. I've merely changed the base. I can write this. This is log 2 base 7 of 7 is effectively just 1. And so I can write this as 2 divided by log 2 base 7, log 2 base 7 of x. And I'll add that to log 2 base 7 of x equals 3. Multiply through by log 2 base 7 of x. If I multiply through, this becomes a 2 plus log 2 base 7 of x squared equals 3 log 2 base 7 of x. And just like before, this is a quadratic that we can solve. Move everything to one side, and I have log 2 base 7 of x if squared minus 3 log 2 base 7 of x, not writing well, and I can say plus 2 equals 0. Okay, so thinking of this as a quadratic, I can write, let log 2 base 7 of x be some t. Let t be log 2 base 7 of x. Then we are saying t squared minus 3t plus 2 is 0. Okay, so I can say that t, which is log 2 base 7 of x, must be, using the quadratic formula, it's going to be minus b, which is 3, plus minus the square root of b squared, which is 9, minus 4 times a times c, which is 8 there, everything divided by 2a, which is just 2. So log 2 base 7 of x becomes, from here, 3 plus minus 1 over 2, which is either 2 or 1. So we are saying log 2 base 7 of x is 1, which means x is 7, or log 2 base 7 of x is 2, which means x is 7 squared, which is 49. And these are the answers to our logarithmic equation. Of course, you should put them back into the problem that we started with to see if they hold true, right? If I substituted this 7 there, I end up with 1, so 2 plus, and that is 7, so 2 plus 1 would be 3. And what happens if I substitute 49? Please check and see that the answer you get is the expected solution. All right, here is question number 10. This is also going to call for a calculator. We can at least set it up, and then if we need to, you can use a calculator later. This is already under base 3, so all we have to do is get rid of the fraction by multiplying each term by using log to base 3 of x. And that means what I have here is going to be, I'm going to multiply every term by log to base 3 of x. So then this becomes, the first term becomes log to base 3 of x, everything squared, minus 6, okay, equals, this is going to be log to base 3 of x. This is quadratic, so log to base 3 of x squared minus log to base 3 of x minus 6 must be equal to 0. That's what we have there. Once again, log to base 3 of x can be considered as some t, so t squared minus t minus 6 equals 0. So I can say that t then, t must be equal to, which is log to base 3 of x, must be minus of b, which is 1, plus minus the square root of b squared, 1 squared, negative 1 squared, which is 1, minus 4ac, so 4 times 1 times negative 6 is negative 24, so it's going to be plus 24 there. Everything over 2a, which is 2. Clearly, log to base 3 of x is the same as 1 plus minus 5, okay, over 2. The value, possible values here, 6 over 2, which is 3, or 1 minus 5, which is negative 4 over 2, which is negative 2. So we are saying that log to base 3 of x is 3, which is to imply that x is 27, or log to base 3 of x is negative 2, which is to imply that x is 3 power minus 2, that is, that x is 1 over 9. Okay, these are the potential or the possible solutions to that logarithmic equation we started with. These are very, very easy questions, and the more you do, the better you get at them. I'm going to show you a few more questions, but I'll not solve them. If you want to see my solutions, I will have posted them in the playlist that contains problems. So just go in there and check, and you should be able to see these questions there. So here are a few more examination type problems that you should try. You will find I will have posted from C11 onwards. I will have posted them in the playlist. So take a look. Here's one. Question number 11 is to solve this. Of course, the best way to solve this would be to use logarithms. Okay, take the logarithm of both sides and see what you end up with. Next, 12 says solve the following. Here is a logarithmic equation already given. We've solved already a number of these, I think like 3 or 4 of them already. So this is already fixed for you, so you just need to let log to base 2 of x be some unknown value, say t, and proceed to solve the quadratic equation. Here is C13, ln of 8, this is log to base e of 8, plus ln of x minus 6 equals to ln of y. So this is a simultaneous equation. 1 is ln of that, and 1 is given by this. So solve for x and y. It is a simultaneous equation. So if you check my solutions in the playlist, this is a typical examination question. Please try it out and see what you get. Of course, what you want to do is to rearrange the first one so that, maybe I can show this quickly. So this is equation number 1. So let this be, this one here be equation number 1, and then this other one here is my equation number 2. What we need to do with equation 1 is to rearrange it so that we get rid of the logarithm in it. So ln of 8 plus ln of x minus 6, I can put those together because we are adding the log, so I can multiply. So I can write this as x minus 6 must be equal to 2 ln of y. I can move y up, and I have ln of y squared. And so clearly you can see that 8 into x minus 6 is the same as y squared. So now I've expressed equation 1 that is, without necessarily without having the log on it. So now I have this together with 2y minus x equals 2 as my equation 1, or equation 1. This equation 2, this is equation 1. And now we can solve this simultaneously. What do we do? Of course, we want to make x the subject here and substitute it there, right? Here's another problem set. So those were a few questions there, and here are another number of questions that I want you to try out. Please try these out, okay? Question C is another simultaneous equation that you need to solve for x and y. These are all examination type questions. Here is another set that you should try out. So you'll just pause the video and solve the set of problems, and then go check the solutions in the playlist. Okay, here are others. Okay. Yes, so there we go. Try the problems and let's see what you come up with. I believe this brings me to the end of this video. If you like what you saw, please get in contact, like the video and share it widely. If you're seeing this for the first time, consider subscribing to the channel and sharing these videos with your friends so they can also benefit from the discussion we've had. All right, thank you. I'll see you in the next video.